In AI, you always hear bigger is better. Today, we're going to put that idea to the test.
Does a more complex model actually guarantee you're going to get better results? Is that always true?
All right, let's just dive right in with a real experiment and see what the data actually tells us. We're pitting 5 different sizes of the famous ResNet model against a standard image classification task. We're going to keep an eye on 2 things: how accurate they are, and just as important, how much they cost to run.
And boom, here are the results. This table tells a pretty surprising story about what's actually efficient.
This chart makes it even clearer. You can see accuracy slowly creeping up, but the training time, it just explodes.
Okay, so let's just focus on the 2 extremes, the smallest model versus the absolute biggest one. Get this, the biggest model took 13 times longer to train on the exact same hardware. And what's really wild is that huge jumps in size sometimes gave us next to nothing in return.
So what's going on here? Why did adding so much more power give us such tiny improvements?
Well, it all comes down to a really cool concept called the receptive field.
See, on these tiny little images, a massive network is trying to find patterns that just aren't there. In other words, the model is basically overthinking a simple problem and wasting a ton of energy.
And that brings us to the real key lesson here. It's all about finding that efficiency sweet spot.
You can think of it as your cost per percent. What are you paying for each tiny gain in accuracy?
And for this job, turns out the smallest model, ResNet-18, had the absolute best balance of the 2.
So, the big takeaway? It's not about picking the biggest tool. It's about picking the right one. Which leaves us with the one big question you should ask for any project. Is that huge cost worth the tiny gain?